Hi, I'm Toups, she, her pronouns, and this is ICU, a design framework for interface cues about agent visual perception from a thematic analysis of video games. My colleagues are Matthew Rueben, Matthew Horrocks, Jennifer Martinez, Michelle Cormier, Nick LaLone, and Marlena Fraune. For our first example, we're looking at a Mario game where the ghosts basically indicate that they've been spotted by hiding their faces. The avatar over on the platform is looking at them currently. When she looks away, they spring into action, and when she looks back, they stop again. This is one way that video games sometimes communicate when one agent has spotted another. What we're doing in this work is looking at how video games surface this sighting information with the intent to use it to design better human-agent interactions that support situation awareness. Our use cases centered originally around disaster response, thinking about rescue robotics. How do survivors recognize that they've been noticed by a robot? Where do they stand to be picked up by a robot? But there are also more general use cases around like public places. As robots and virtual agents proliferate, we want to know that they're paying attention to us and that they're going to avoid hurting us, for example, by running into us. So to establish a few terms real quick, in this research, the player refers to the human playing the video game. The player's agent is basically what they control in the video game, and the non-player agents are the other characters, avatars, and actors in the game, machine otherwise. We consider a sight cue to be any perceptible stimulus that indicates one agent visually perceives another agent. We put visually perceives in quotation marks because agents don't actually visually perceive each other in video games. It's essentially a mathematical calculation based on the geometry of the game world and the sensor characteristics. A sighting is any event in which a perceiver takes notice of a visual target, right? So anytime some agent in a video game notices another, that's what we're interested in. Two other kind of key terms, line of sight, essentially the line from whatever visual sensors the agent has to the agent they've spotted, and the field of view indicates the space in which an agent might be spotted or might be sighted. So our methodology, very briefly, there's much more detail in the text. It was a qualitative approach. We had a number of meetings fairly regularly to undertake a thematic analysis. We essentially collected games based on our personal experience, spinning out from other games, looking at various resources online, and essentially we started to identify sight cues, right? These moments where the game indicates that one agent has sighted another. They don't necessarily have to be visual, right? That could be a point of confusion. We then started describing these. We used a set of questions to guide how we describe them. And then once we have the descriptions in place, we could use those to build out themes, look for connections between games, and those themes led us to building out a framework. So our characteristics of our corpus, we had 39 games, including 2 game series. Out of these, we identified 60 sight cues, and the corpus really favors action games and stealth games. It's kind of games where it really matters when one agent sees another, right? Where that's really core to the gameplay. So our framework, very briefly, again, there's much more detail in the text, but I'll walk through several examples and how to use it. So we essentially split things into the high-level category, right? The location of the visualization or the sonification, and then some description of what is actually being signified to the player, and then what information does that contain. So all of the cues that we have indicate detection and attention, but some of them vary on how they can show line of sight and field of view, these things that are less certain and really related heavily to the sensors that an agent possesses. So the little X means that it was not feasible. The filled dot means that we had an example. The empty dot means we expect there to be one, but we couldn't find one. And the question mark means it's unknown. In addition to visualizations, we also looked at sonifications, but we did not look at any other types of stimulus. So if we look at a few examples, maybe start with perceiver behaviors, right? Our agents might move around and change how they act. They might point their heads or their bodies or their eyes toward the thing that they're perceiving. We also might see scenarios where the target itself actually is the thing that acts differently instead of the perceiver, like the ghost that we saw earlier. If we look beyond, there are a number of scenarios where essentially games leverage the fact that they have a user interface and like a HUD and essentially communicate these sort of metagame things around using symbols and icons. And then several of them have a whole slew of cues that happen all together that include combinations of diegetic things that are happening in the game, visualizations that are happening in the UI, as well as audio cues. And a key part of this work was kind of teasing all of those things apart. Again, more detail in the paper. So if we want to make use of the framework, right, it's worth noting that we use it to answer questions, right? There's no particular way that you're supposed to enter the framework. As you have questions in designing a human-agent interaction, you can go into the framework and essentially see what kinds of capabilities do I need, what can I do with the capabilities I have, and so on. So let's think about a quick example. If we have an anthropomorphic robot, what could we do, right? Maybe for our example, this robot, its eyes can't really move around, but it can turn its head, and it's fixed in a particular location. It has like basically like an upper body, right? Hello, hi robot. Our robot is the perceiver. So we'll take a look at the potential perceiver behaviors, right? We can turn our robot around. We can gesture. We could wave at people, right? We could change pose, right? We could show that the robot has noticed someone. Hi again, robot. So of course, all of these things enable us to indicate attention or detection, but they don't tell us anything about the field of view or line of sight. We don't really have a way to communicate that with this robot as it is. So if we wanted to be able to do that so that people know, say, where to stand in order to interact with the robot, right? Maybe we could make the eyes more interactive. Maybe they could track people and make eye contact, right? In order to sort of signal where the robot can see. We might have our robot have a projector on its chest that would enable it to show sort of where you have to stand in order to interface with it. If we start thinking about augmented reality as a possibility, maybe looking at it through a phone interface or through some sort of other augmented reality, we could use these kind of icons and other signifiers that we superimpose. We might even show sort of the area that the robot can be interacted with in. Also, if we could do work with the space that it's in, right, we could add projectors and other things that basically indicate data in the space. So ultimately, the whole purpose of the framework is to enable designers to ask questions about their design and to surface these questions around essentially situation awareness and our ability to know when and how we can interface with an agent. And this has been ICU, a design framework for interface cues about agent visual perception from a thematic analysis of video games. Thank you.